Yeah.
Yeah.
$20.
What? Ay.
That's a steal.
All right, half angle identities. We are going to fill them in on the notes page and then fill them in on the identities page. So sine has 1 with a plus minus option, cosine has 1 with a plus minus option, and then tangent has 1 with a plus minus option, and then 1 without. So there's technically 2 within 1, 2 within 1, 2 within 1, and a third. So plus minus, big square root because there's a fraction underneath it. So the numerator is the binomial 1 minus cosine of theta all over 2. Angle is plus or minus cosine all over 2. So these are very close to one another. The way that I keep them straight is like cosine is cosine, so it's a plus. Like it makes sense that for the cosine's identity, it's a plus. Like it, I don't know, that's how my brain works. Like it just kind of makes sense. Like I'm cosine, so I'm plus. But then sine is not cosine, so it's the one that has the minus. Tangent, plus minus. Anybody want to give the first one a whirl? No. Think about tangent. It's what over what? Sine over cosine. Say it again.
1 minus cosine.
That's it. 1 minus cosine theta over 1 plus cosine theta. So it's sine's numerator over cosine's numerator, because technically it would be 1 minus cosine theta over 2 over 1 plus theta over 2. And when you keep flip chains, the 2's would cancel, leave you with the 1 minus over the 1 plus. And then the second one has no plus or minus. It has no square root. However, it is a fraction. So this is your second one. This one is sine of theta over 1 plus the cosine of theta. So when you are asked to do a half angle for tangent, you want to choose this one for 2 reasons. One, the sign is like already built in. If the answer is supposed to be positive, when you plug in the correct ratios, it'll come out to be positive. If the answer is supposed to be negative, it'll come out to be negative. On this one, you have to decide either at the beginning or at the end if it's supposed to be plus or minus. So there's a decision to be made, which one you choose here, and you're working with a radical. So you have to, rationalize denominators, stuff like that. So this one's just easier to use. Over there, sine and cosine, you have to choose a plus or a minus, either at the beginning or the end. We choose it at the beginning. I'll teach you how to do that, so no fret. But notice how it's different than the double angle. When we did double angle identities, theta was literally multiplied by 2. That's why they called it double angle. Theta is being divided by 2, so it's being cut in half. All right, so go ahead and copy these down, and then I'll talk about how we determine signs here. So your next memory quiz is Monday. So you'll fill in the whole chart Monday. They kind of look like faces. All right. So when choosing signs, S-I-G-N-S, it's based on the quadrant. If your trig word is sine, sine is associated with the y values. So you would choose the y value of the angle's quadrant. Cosine is associated with the x's. So you would choose the x value of the quadrant that your angle is in. But you're not just choosing the quadrant that the angle is in, you're choosing where its half angle would be. So we're going to practice that before we start. So let's say that you have an angle between 0 and 90, 60 degrees. Okay, so let's say theta was 60. Theta over 2 would be 30. 60 degrees is in quadrant 1. 30 degrees is in quadrant 1 as well. Any quadrant 1 angle, when it's cut in half, where does it have to land? Has to land in quadrant 1. So the x's, the cosines are positive, and the sines, the y's, are positive. So if your angle is, when you cut in half, it will be quadrant 1. If the y is positive, so you choose the positive root. Let's say that your angle in quadrant 2 between 90 and 180. Let's pick 100. Yeah. That's not a theta, that's a q. Theta is 100. It starts off in quadrant 2, but you don't pick the signs based on its original quadrant. You pick the signs based on where it's cut in half. So if theta is 100, what's theta over 2? 50. Well, where would 50 land? In quadrant 1. So now you would pick the signs from quadrant 1. X's are positive, Y's are positive. Let's say that we have a quadrant 3 angle between 180 and 270. I'm going to pick 200 because it's easy to cut in half. So let's say we had 200 degrees for theta. I think you're writing Q. Theta. That's clearly quadrant 3. When you cut that in half, what's half of 200? 100. Well, where is 100? Bigger than 90, right? But less than 180, so it lands in quadrant 2. Now your S-I-G-N-S signs are negative positive. So if we're working with the cosine, we choose the negative. If we're working with the sine, we choose the positive. Let's say you have an angle in quadrant 4. All right, theta this time. Between 270 and 360, I'll pick 300. So if theta is 300, we start off in quadrant 4, cut that in half, we're at 150. What quadrant does that land in? Lands in quadrant 2. So then you would choose your signs based on quadrant 2's angles. Okay? So when we start cutting in half, you have to be able to know where it lands. Sometimes you'll know specific angle measures, sometimes you won't. But just think about Q1, Q2, Q3, Q4, like the numbers 1, 2, 3, and 4. This might even be easier for you to think about. If you take the number 1 and cut it in half, 1 cut in half is a half, right? So that would have to land in quadrant 1. Half of 1 is a half. Has to land in quadrant 1. What is half of 2? 1. So where would these halves have to land? In quadrant 1. What is half of 3? 1.5. Well, 1.5 would have to be in quadrant 2. Bigger than 1, but less than 2. 4 cut in half. 2. That's another way to think about it. All right. Let's do this thing. Use the information to sketch where the given angle is located and state the x, y, and the her. So we are not doing any actual problems on these. we have to figure out the clues. This is the clue game last time, except they step it up a level. If you can't get the if you can't get the correct quadrant, say that, correct quadrant 5 times fast. Go.
Correct.
Correct quadrant, correct quadrant, correct quadrant, correct quadrant. Not quite, it turns into quack. All right, so if you can't get the correct quadrant of the angle, then the axis away and her wrong, then everything you plug into your trig identities comes out wrong. So this part's like super important. All right, so first thing we have is our trig word is cosecant. Trig word is cosecant, followed by the angle theta equals our ratio. We are going to write 3 as 3/1. So that we see it as a ratio and not just as a whole number. So cosecant is what over what? 1, true. Ratio, like SOHCAHTOA CHOSHIKEO. It's the H over the O, right? So the 3 over the 1 is the H over the O. Or the her over the oi. Notice that the Y is positive. And the her is positive as well. What quadrants have positive Y's? Above or if you're cross-hatching, go horizontally. So that's half of our clue. We know our angle either has to be in quadrant 1 or quadrant 2 because the Y's were positive. The other half of the clue is that the secants of theta are less than 0. Less than 0. What type of numbers are less than 0? Negatives. So this is saying that you have negatives. Like you have to understand that less than 0 means negative. What if it's a greater than 0? Positive. And then they're giving you a clue about the secants. Secants are the H's over the A's, correct? The CHOSHIKEO, because it's the reciprocal of cosine. So the H, remember the hypotenuse of your triangle can't ever be negative. So the negative that it's referring to is the X portion. So they're telling you that the axes are the negative values. Let me do that again. Less than 0 are negative numbers. Secants deal with the H over the X. H can't ever be negative, so this clue is saying that the negatives belong to the X values. What 2 quadrants have negative X's? So think about your number line here, right? So the 2 quadrants would be 2 and 3. So with your blue or your pink, or make a vertical crosshatch if you're just using normal pencil. So where the overlap of your yellow and blue makes green or your yellow and pink makes orange, a blue and a pink would have made a purple. I guess you could have used blue and purple or blue and pink if you had that. If you're just doing cross-hatching with the horizontal and the vertical, it's the overlap. So we're looking for the green, we're looking for the orange, whatever, wherever your overlap is. And some of you won't even need to do this. Like this is just a visual so you guys can see it better. What quadrant does our angle theta have to be in? Has to be in quadrant 2, the overlap. So we're going to draw the hypotenuse of our triangle, which is the terminal ray of theta. We're going to create the right triangle to the closest x-axis. We know that our hypotenuse has to be what? 3. Clearly, you're not on the unit circle because what's the hypotenuse of the unit circle? 1. We know that our OI, the Y value, has to be 1. We know hypotenuse is 3. The y value is 1. We're left to find what? The x. How do we find the x? Pythagorean theorem. We're going to have 3 squared equals 1 squared plus x squared. 9 equals 1 plus x squared. Subtract to get 8. Square root it, you produce 2 answers. Remember that x's and y's can be positive or negative, and you choose the appropriate sign for the quadrant that your angle is in. The x's are negative, so we're going to choose the negative answer. But what do you know about square root of 8? Square root of 8 can be broken down into the square root of 4 and the square root of 2, which gives you 2. So x is negative 2 root 2. How many of your teachers, I don't know which class you first learned this in, maybe geometry, if you're not like super good with perfect square factors, remember you can do a factor tree like this. So you can do 2 times 4, 4 splits into 2 and 2, and then you lose any 2 numbers that are the same. So this 2 is like the 4. You know what I'm saying? Because 2 times 2 is 4. The square root of 4 is 2. So you take 1, 2 in front, and then the number that's left stays under the radical. That's another way. It's called a factor tree. That's another way to do it. All right. So we have this was just like practice. If you can't get to the correct quadrant and find your correct axoid and her, then the rest of the problem's wrong, and that super stinks. Number 2, practice finding the quadrant. We've got the secant of beta equals negative 2. So first we're going to make the negative 2 be negative 2 over 1. So secant is what over what? True, but what's the ratio? H over A. So the her over the x. And look at this for a minute. After you labeled the negative 2 over 1, the her and the x, you've got a negative fraction. And it's written as being upstairs next to the hypotenuse, but the hypotenuse can't ever be negative. So that negative doesn't really belong to the hypotenuse. Who does it belong to? It belongs to the bottom, but it's just making the overall fraction negative. So really it's 2 over negative 1. So that clue is trying to tell you that the x's are negative. What quadrant has quadrants have negative x's? 2 and 3. So once again, why did we make the negative go downstairs to the 1? The hypotenuse can't be negative. All right, second part of the clue is that the cosecant of beta is less than 0. So when you see less than 0, your brain needs to think what type of numbers? Negatives. Cosecant is h over o. So if the h can't be negative, they're trying to tell you that what is negative? The y's, the o's. So the o's are the negative this time. Quadrant have negative y's. 3 and 4. The overlap occurs in what quadrant? 3. So that means beta on this one, beta have to be in quadrant 3. So we make our hypotenuse, the terminal ray of theta. Draw it back to the x-axis for the right triangle. And then we know two of our numbers. We know that the hypotenuse is 2 because that came from the secant clue. We know that the -1, which came from the secant clue. And we're left to find y using Pythag. So 2 squared equals 1 squared plus y squared. 4 equals plus y squared. Subtract 1, 3. Square root, so we get plus or minus the square root of 3. We know that we're in quadrant 3 where the y's are negative, so we have to choose y is negative root 3. And can that simplify? Can that so we just leave it as negative root 3 for the OI. All right, so now we're going to do the real thing. We're going to use the clues to find the quadrants, figure out our axoids and hers, and then it's what we did yesterday where we fill in the identity, fill in the ratios, simplify the problem. So number 3 says cosecant of theta is 5 over 3. Cosecant is what over what? Hypotenuse over opposite is the h over the o. So 5 over 3 is the her over the oi. Notice that the fraction is positive. 5/3 is positive. So they're telling you that the y values are what? Positive. So what quadrants have positive y's? Ooh, wrong color. Second part of the clue says that the secants are less than 0. Less than 0 means negative numbers. Secants are h over a. And since the h can never be negative, they're trying to tell you what? That the the adjacent values are negative. So they're telling you that the x's are negative, which is what quadrants? Negative x's, 2 and 3. So then the overlap places us in quadrant 2. We draw our terminal ray, which is the hypotenuse of our right triangle. Drop it down to the positive, or drop it down to the x-axis and make your right triangle. We know two numbers. We know from the first clue we've got a 5 over a 3, so the 5 is the her, our hypotenuse. We know the 3 belongs to the oi, the y. And then if you know the most famous Pythag triple, when 5's the hypotenuse and 3's a leg, the other missing leg has to be 4, except we're in quadrant 2, so it's a negative 4. So you can use your knowledge of a Pythag triple, or if you need to work out 5 squared equals 3 squared plus x squared, do that thing, x equals negative 4. All right, so that's the first half. Now we got to work with beta. Gives us the tangent of beta equals 2/3. So we know 2 over 3 is the oi over the x because it's TOA, it's opposite over adjacent. Second part of the clue says, hey, beta, so if you read it this way, it's less That's horrible cursive. Less. Oh, wait. Oh my gosh. Less than 3 pi over 2. But you read it this direction, and it says beta is greater. Greater than pi. So 3 pi over 2 is down at 270. Pi is at 180. So 3 pi over 2 is down here. Pi is here. And beta has to be squished between those two numbers. So it's going to be what quadrant? 3. So this tells us Q3. What do you guys know happens in quadrant 3? Yeah, both the signs are negative. So the OI and the ax are actually -2 and -3. OI is -2, ax is -3. Draw that right triangle. -2, -3. Now, 2, 3, 4 is not a pi fact triple. We're going to have r squared equals -2 squared plus -3 squared. Yo. Oh, I did flip flop it. Thank you. Not weird. You're going to say. It's not weird.
No, because like you might have realized it right when I said.
Right when you said it, Miss Mary, you wrote the dang it. So -2 is the y. That was my bad. Thank you. And -3 is the x. Still going to add them. We get 4 and 9, which gets us to 13. When you square root it, you get a plus and a minus, but keep in mind you're solving for the hypotenuse, the radius of the circle. So it has to be positive. Can 13 simplify? Oh, 13 is what? Prime. 1 and 13 are its only factors, so it's going to stay as root 13. All right, so now you've earned 6 points. The ax, the oi, and the her for theta, the ax, the oi, and the her for beta. All of these values are going to be used in the rest of the problems. The rest of the problems are 3 points apiece. Writing the identity, plugging in the ratios, simplifying the answer. So what's tangent of theta plus beta? This is a what identity? It's got an addition between the two angles. It's a sum identity for tangent. So remember that tangents are fraction. So we're going to have tangent of the first angle. Signs upstairs stay the same. Tangent of the second angle. And then you get 1 with a minus. Sign changes on the bottom. And then we multiply the 2. So now you've earned 1 point. All right, next point is going to substitute in the correct values. It was the tangent. So we need the O over the A from theta first. What is the opposite over the adjacent from theta? -3/4. And it doesn't matter where you put the negative. You can go upstairs, downstairs, or out front. Just don't lose it. Plus, we need the tangent from beta. So we need the opposite over the adjacent for beta. So that -2 over -3 will just be the 2/3. If you want to put both of the negatives, you can, but they obviously divide out. Over 1 minus, I'm going to write 1 as 1 over 1. 1 over 1 minus, and then we put in tangent of theta, which was the -3/4, times the tangent of beta, which was the positive 2/3. So your second point is earned correctly substituting in, and then we math it up. Upstairs you have a fraction plus a fraction, so we need common denominator. So what's our LCD between a 4 and a 3? A 12. So we're going to have times 3, times 3, times 4, times 4. So we get 9 over negative 12 plus 8 over 12. Downstairs, we would have 1 over 1. And then do you need a common denominator to multiply? No, so we'll have a negative 2 times it, or sorry, a negative 3 times a 2, which is negative 6 over 12. So 1 minus negative 6 over 12. Upstairs, negative 12 plus 8 twelfths gives you negative 1/12 over. Downstairs, the minus negative becomes a positive, and then we need 1 over 1 to be 12 over 12. So 12 twelfths plus 6 twelfths, 18 twelfths. Multiply by the reciprocal, times 12 eighteenths. Cross cancel the 12s, leaves you with negative 1 over 18. All right, part B, 2, or the tangent of 2 beta. So is this one a sum identity? What is it if you have 2 times beta? It's a double angle. So we need the double angle identity for tangent. So we have the fraction again. What's upstairs? 2 tangent beta. Make sure you're using beta. Over 1 minus tangent squared of beta. We substitute in. Tangent of beta was what? 2/3. So upstairs, we'll have 2 over 1 times 2 over 3 over 1 over 1 minus 2/3 quantity squared. Now let's math it up. 2 over 1 times 2 over 3 gives you what in the numerator? 4/3, top to top, bottom to bottom, over 2/3 squared will be 4/9. So you'll have 1 over 1 minus 4 over 9. We need the 1 over 1 to become 9 over 9. So 9/9 minus 4/9, 5/9. So we get 4/3 over 5/9. And then what? Multiply by the reciprocal. Make sure you flip it. 9 lands on top, 5 lands on bottom. What could you do to make it easier? Reduce the what with the what? So 3 goes into 9 thrice. So we would have 4 times 3, which is 12 over 5. Next one, so exciting. Hey! Oh, you turned something in?
Yes.
Appreciate it. You're the best.
Yeah.
Moved up to number 1. Yeah, watch out. Fuck with that. Hey, told me I had to change it. On who?
I'm not the expert. I am. See?
You are.
I'm Spanish too.
Ooh.
Yeah.
Dope.
Wait over here, Albania.
That means bathroom.
Yeah, actually. That's only.
I just knew the Albania part.
El Burro sabe más que tú.
Je suis la fromage.
What?
Je suis la fromage.
French?
Oui. Adios. I am the cheese. Cheese. Je suis la fromage. Je suis la queso.
That's such a donkey.
Ooh. So the sine of beta over 2. So notice your angle is beta. So everything we're going to reference comes from beta. What's happening to beta? Being divided by 2. So this is a half angle. So our identity is plus or minus big ginormous square root. Fraction underneath. 1. I'm not cosine. So on minus, the cosine, don't write theta. Beta over 2. All right, so we got to choose a sign. It can't be both. It's either plus or minus, but not both. So beta, so I'm going to scroll back up to the picture. Beta was in quadrant 3. So I am taking half of a quadrant 3 angle. Like if you need to pick a degree between 180 and 270. 200. Cut that in half. 100. Where did we land? Quadrant 2. Where the S, I, G, and S, where those signs are, X's are negative, Y's are positive. And you choose the correct sign based off of the trig word and the quadrant. Plus, why? Because sine is the y's. So positive is what our final answer will be. We will get a positive root. All right, so now we're left to substitute in. So you don't carry the plus minus around with you anymore. It's just the positive. So we're going to have 1 over 1 minus cosine is adjacent over hypotenuse, and make sure that you pull the a over the h from beta's values. So a was negative 3, h was root 13. All over 2. The minus the negative will become plus. We are adding 2 fractions, so we would need an LCD. What would the LCD be? Root 13. So root 13 plus 3 is not 3 root 13. Like you don't get to squish them together. It's just 3 plus the square root of 13 over that LCD of the square root of 13 all over 2. So underneath this radical, you have a fraction divided by a fraction, because the 2 is 2 over 1. So fraction divided by fraction, what do we do? Keep flip change, so we're going to multiply by 1/2. So we'll have the square root of 3 plus root 13 over 2 root 13. And then we need to rationalize. You don't want a root inside of a root. Uh-oh, turn over. We're going to multiply by root 13. Oh, you're so kind. So when you take the root 13 times the binomial, make sure that you distribute. So we'll have 3 root 13 plus 13, because root 13 times root 13 is square root of 169, which is just 13, over 26, because it becomes 2 times 13, which is 26. Now, technically, this is technically you still have a radical in the denominator, but no, we're not going to worry about rationalizing because it's really like the top and the bottom can be separated into radicals, and then you can rationalize with the root 26, but we're not going to. So this is your final answer. Okay, when you flip it over, it's not a new problem. We just have parts D, E, and F. I wrote the little chart for you guys to just copy it over. So what we did here on the front, copy over to the back. So we had, that way we don't have to keep flipping over when we do our ratios. All right, cosine of theta over 2. So we have what type of an angle? What's happening to theta? It's being chopped in half. So we need the half angle identity for cosine. So we've got plus minus, big square root again. It is cosine. So it's 1 plus upstairs. Don't write beta. Our angle is theta. All over 2. We need to choose the appropriate sign. So we're taking half angle of theta. Theta is in quadrant 2. When you cut an angle in half from quadrant 2, I'll pick 100. Half of 100 is 50. What angle do you land in? No matter what angle is in quadrant 2, when you cut it in half, it has to land in quadrant 1. So now we're in Q1, where the SIG and S signs are positive, positive. This one you kind of get lucky because they're both positive, but you choose the X because the trig word was cosine. All right, now we substitute. Make sure that you use theta's values. So we can drop the plus minus portion. We'll have 1 over 1 plus. We need cosine's ratio from theta. So we need the A over the H from theta, which would be -4/5 over 2. We're adding fractions upstairs. So the 1 over 1 needs to become 5 over 5. Just got a big whiff of like rose. Anybody else smell it? Well, you guys have your masks on too. All right, so 5/5 plus -4/5 gets you 1/5 over 2 over 1. Keep flip change, copy dot flip, multiply by the reciprocal, 1/2. So we get the square root of 1/10. This one we will simplify. This one's a lot easier to simplify than this one. So this one can technically, you may not remember this, but be split into the square root of 1 over the square root of 10. That's a legal move. Square root of 1 is 1. And then how do we get rid of the root 10? Multiply by root 10 on bottom and on top. So that's called rationalizing the denominator. Did this in geometry today. Woo! So we get root 10 over 10. All right, party. We got the tangent of theta over 2. So we've got what type of an angle? A half angle again. A half angle for tangent. Remember that tangent has 2 identities. The easier one to choose, or actually it has 3 identities, plus and minus, but the second one after the equal sign is the easier one to choose because it will have the built-in sign, whether it's supposed to be a positive or a negative, and you don't ever have to rationalize the denominator. Well, unless you had a root, I suppose. But, all right, so we want to do the one with sign on top. So this is equivalent theta over 1 plus cosine theta. So the top needs signs ratio, the O over the H from theta. O over H from theta is 3 over 5. 1 over 1 plus, and we cosines ratio, which is A over H, so take the A over the H from theta, which is negative 4 over 5. Upstairs doesn't need to be simplified because it's one fraction, but downstairs we are adding. So we need an LCD. 1 over 1 becomes over 5. 5/5 plus negative 4/5. 1/5. So we have 3/5 divided by 1/5. Flip it. 5 over 1. Cancel it. Leaves us with 3. I have both of them worked out on my answer key. It's just more work with your radicals to end up with a 3. And you have to choose a sign. I also have part F worked out. And it's crazy ugly. But we're going to do this. If you're interested in seeing it later, I can let you see the paper. But we're going to do the shorter, easier one for beta as well. So we have a half angle for beta. Make sure that you don't expand it with theta. So the sine of beta over 1 plus cosine beta. And make sure you put in numbers from beta's table. So we need the O over the H from beta, which was negative 2 over root 13 over 1 over 1 plus negative 3 over root 13. One over 1 needs to become root 13 over root 13. So we'll have the upstairs, which is negative 2 over root 13, all over root 13 plus negative 3 is negative 3 plus root 13, all over root 13. Or you could write it, you could have kept it as root 13 minus 3. All right, so now you have fraction divided by fraction, so we need to copy it out, flip, keep flip change. So we get a root 13 on top, convenient, over negative 3 plus root 13. So we get negative 2, the root 13's cancel, over. I'm going to go back and I'm going to flip this guy because you guys might find the conjugate easier if you see it as root 13 minus 3. So we have to rationalize the denominator by multiplying by the conjugate. Remember the conjugate keeps the same terms, but you change the sign in the middle. So we'll multiply by root 13 plus 3, applying that makeup. So upstairs we distribute the negative 2. We get negative 2 root 13 minus 6 over, then downstairs we need to FOIL. Root 13 times root 13. 13. Root 13 times 3. 3 root 13. Negative 3 times root 13. Negative 3 root 13, which is what we want to happen because we want those boys to cancel. And then negative 3 times positive 3. Negative 9. So the 13 and the negative 9 get you 4 in the denominator. So remember, this is really two fractions combined into one. It's negative 2 root 13 over 4 and a negative 6 over 4. So we reduce negative 2 root 13, oh my gosh. Negative 2 root 13 over 4. Don't lose the negative. So we get negative root 13 over 2. Over here we get minus 3 over 2, which is just negative root 13 minus 3 all over 2. If you can simplify, without separating out the two fractions, like if you can just do that and that, that's fine to go from here to here. Or if it helps you to separate it into two fractions to reduce, more power to you. If you're curious, the other answer to this, if you work out the tangent of beta, the half angle with the other identity, it's negative square root of negative 11 minus 3 root 13 all over negative 2. And both of these have decimals of negative 3.3, if you were curious. So this is what you get if you did the other identity. All right, 1045, you got 15.